In this video, we are going to learn about Python modules. What is a module? A Python module is a Python file containing a set of functions and variables to be used in an application. So, for example.py is a Python file and it is a module. And example is the name of the module. So example.py is a module. Now what are the advantages of modules? Why we are using a module? First of all, it breaks down large programs into small, manageable and organized files. That means big programs can be broken down into small pieces. Second one is reusability. That means once we created a module, that same module can be used in another programs. Third one is reduce the complexity of a programs. It will reduce the complexity into a large extent. Now Python import statement. After creating a module, we have to import this statement. First one, using import statement. The syntax is import module name. For example, import example. And this can be accessed, the file function can be accessed with the syntax module name dot function name. For example, example dot fun. Second one is Python's from statement. Syntax is from module name import function name. For example, from example import fun. Here fun is the function and example is the module. Third one is using import star statement to import all names from a modules. Syntax is from module name import star. Example, from example import star means all the functions from example will be imported. Modules can be either built-in and user defined. Same like functions, we can define a modules or we can use already defined modules. That is called built-in modules. Now we are going to learn about some built-in modules. First one is math modules. This module is used for mathematical tasks. Maths modules contain some methods and constants. First one is pi. This constant will return the pi value. For example, 3.1415. That is the pi value. Second one is e. This constant returns Euler's number, the base of the natural logarithm. Now we can take this pi and e constant in Python. That is import math. We already learned that we have to import all the modules. So here pi is the function of math module, so we are using import math. Now print math, that means module dot pi. So here pi is the constant and math is the module. Now if you are running these programs, we will get the pi value, that is 3.14 etc. So here pi is the constant, math is the module. Now we will go for e constant. We'll remove this pi and we'll write e. So this e is a constant of math module. Now run these programs, we are going to get the e value, that means 2.71 etc. So here e is the constant and math is the module. Now the next math module is sqrt. This function is used for finding the square root of a given number. syntax is math dot sqrt of x, where x is a number. Now we can check this square root function in Python. Import math x is equal to 36, print square root of x. So here the square root of x is, then math module dot name of the function square root. So this function square root will give the square root of 36, that is 6. We'll check this output. So we are going to get 6. So square root of x is 6. So that is square root function. Now we'll check for another example. X is equal to 100, then print the result. Now the square root of x is 10. Same way we are going for another example. X is equal to 24. Since it is not a perfect square, we'll get square root is 4.898, etc. Next function is ceil function. This function or this method in Python returns ceiling value of x if x is the argument, that is the smallest integer not less than x. So here x is the argument passed with this function ceil. And next one is floor function. This method in Python returns floor of x, where x is the argument, that is it returns the largest integer not greater than. We are going to check these ceil and floor functions in Python environment. Import math, since math is the module where the ceil and floor functions are saved. So x is equal to 25.7. Now print ceil of x, print ceil of 25.7. While running this, we'll get the output as, we'll get an error. Here we'll get an error because you know what has happened. Here you can see that we are not included math with these functions. So syntax error. Now we will change here, that is we are going to add the module name .cel, math.cel. So always we have to use to access a function module name first. So here we are going to get 26. So 26 is the ceiling of this 25.7. Now we will test another example. X is equal to 26.9. This will give 27 as the result. So here we are getting 27, but we have given 26.9. Now we'll go for floor. Math.floor of x gives 26. 26.9, while flooring will get 26. Another example, 26.2. Here the flooring value is again 26. Now x is equal to minus 26.2. Here we are getting minus 27, not minus 26. We are going to get minus. The next function is power function, POW functions. These POW functions returns the value of x to the power of y, x raised to y. Next one is fabs. These fabs functions returns the absolute value of the number. So power as well as fabs are the other functions under this math module. Now we'll check this in Python. Import math, because math is a module. We have to use power. X is equal to 2 and y is equal to 3. Now print math dot POW, that is power of x comma y, x raised to y, that is 2 raised to 3. So we will get 2 into 2 into 2, that is answer is 8. So this gives the power of two numbers. So another example will give x is equal to 25 and math dot f abs. So it will give the absolute value of x. Absolute value here it is positive 25, always gives positive 25 as the answer. So 25 is the correct answer. Now we will go for another value, negative 25. The absolute value of negative 34. The absolute value of minus 34 is positive 34. So we'll get the output as 34. So these f, abs and powers are other functions under this module. Now we will go for some trigonometric functions under this module, math, sine, cos and tan functions. So sine functions returns the sine value of a argument passed, and cos value functions returns the cosine of value passed as argument, and tan function returns the tangent of value passed as argument. So sine, cos, tan are the three functions under this, another three functions under this module. Now we'll check these functions in Python environment, that is import math. As usual we use math as the module. Now x is equal to 45. We are giving or we are assigning 45 to variable x. Now print the sine value of x is. So we are going to find the sine value of 45. That is sine of x is, then math dot sine of x. Here also math is a module. Now we'll run these programs and we are going to get the output as 0.85 etc. Now what about cosine value of this 45? We'll check it. So print the cosine value of x is, now we are going to write math dot cos of x, so that it will give the cosine value of 45. Now here we can check cosine value of x is 0.5253 etc. Now what is the tan value of 45? What is tan 45? For that we'll go print tangent value of x is math dot tan of x. So we'll get here the tan 45. Now we'll check this. We'll get the output as 1.61 etc. So these are the three functions under this math module, trigonometric functions, sine, cos and tan function. The next module we are going to learn is random modules. Before that, what is random numbers? Random numbers are numbers that occur in a sequence such that the values are uniformly distributed over a defined interval or set, and is possible to predict future values based on past or present. Under this, the first function is random. This function generates a random float number between 0 to 1.0. Second one is randint. This returns a random integer between a specified integers. And the third one is randrange. This returns a randomly selected element from the range created by the start, stop and step arguments. The value of start is 0 by default. Similarly, the value of step is by default. I want to check these random functions in Python environment. So here instead of math we are going to import what? Random. So random is the module. Import random, print random dot, the function name is random. Random dot random. Here there is no arguments passed with random. So this will print any random numbers between 0 to 1. So it will be a decimal number. You can check the output is 0.09. Again we are running the same programs, we'll get another number 0.81. We cannot predict what is next number. Again run it, so you'll get 0.13. so these random numbers are generated automatically by this computer, so we cannot predict what is next number going to produce or going to display. Second function is rand int. So here rand int, we have to give an argument. The range will give 5 to 20. 5 is the lower limit and 20 is the upper limit. So any integer values between 5 and 20 will get displayed. So here we are getting 5. So we cannot predict again. Again if we are running, we'll get another number, that is 18. Again if we are running, we are going to get another number which is called 8. So it will display any integer values. Now the next number is rand range. Here also we have to give a range or arguments. So here we are going to give 3 arguments. First one is start, second one is end, and third one is step. That means by how much this number should be stepped. By default it will be 1. So here it is printed as 19. Again if we are running, we'll get 17. So if we are running, that means changing this step value 2 instead of 2. If we are going to give 5, then we will get 5. That means 5 plus 5, 10 onwards we'll get. So the value is 15. It can be any value from 5 to 20. So we will not get any value that is 6, because it is stepping value is 5. We will not get 6. We will get 5 plus 5. That means 10 onwards. 10 to 20 we are going to get the values. Next module we are going to learn is statistics modules. These modules provides functions to mathematical and statistics of numeric data. The first one is mean. The mean method calculates the arithmetic mean of the numbers in a list. So whatever the list, it will give the mean value. Under this module, second one is median. The median method returns the middle value of numeric data in a list. So in a numeric data, the middle term is displayed. And the last one is mode. The mode method returns the most common data point in the list. That means the repeating values will be displayed. So we'll start with, as usual, we'll start with the import statement. Here the import statement is import statistics, because statistics is the modules where the remaining functions are saved. So list, for example, we are giving a list 2, 4, 6, 10, 15, 20, 25. Now print statistics dot, the first function is mean of the list, that is list. So here it will give the mean of these elements from the list. Here we will get 11.71. So that is the mean value of these values in the list. Now we'll go for the next functions, that is we'll go for median. So median of list will give the middle value of the list. So here we can see that 10 is the middle value. So this middle value gives, that means median will give the middle value. Now for the next functions, we are going to add some more data, that is 6 we are repeating, then again 6 repeated, that means 3 times. Now 2 is repeated. Now here 6 is repeated 3 times and 2 is repeated twice. Now if we are giving mode will give the total, that means the number which is repeated most. So here we are going to get 6, because 6 is repeated more times. So that is mode. Now we are going to recall whatever we learned today in this video. What is a module in Python? We learned how to use it, and what are the use of modules, what are the advantages of modules, why we are using modules, and what are the different types of modules, that is built-in modules and user-defined modules, and finally what are the different functions under math, statistics and random modules.